Hello, hello, Algebra 2B. Here we are with a practice quiz video. Again, I'll be gone for a track meet, so I wanted to leave you with at least something here. We're not going to do all of them. You should have the answer key to this practice quiz in an email or posted online somewhere. So we're just going to kind of pick and choose a little bit. This is the practice quiz for 12.6, 12.7 graphing. So this is just the basic stuff. We're not doing any shifts. We're just focusing on the period and domain and range. We don't have any plus minus stuff going on. I think the top two are going to be pretty nice, pretty friendly there. Let's slide down here to the middle two, the cosine ones. So the 3 multiplier on the inside next to theta, that's going to be your period adjuster. Zoom out just a touch, I guess, here. Okay, so our period is normally 2 pi. But we got this times 3 on the inside next to theta. That's going to make us get done 3 times as fast. So I divide that by 3. So there's the period, 2 pi over 3. Sine and cosine have 4 counting numbers. Okay, so we're going to count by, now this one's a little weird, 2 pi over 3 divided by 4. Okay, that's the same thing as multiplying by, I'm too far out now, aren't I? Same thing as multiplying by 1/4. So this is like 2 pi over 12. We're going to be counting by pi over 6's. Amplitude, there's nothing in the front, so it's just a 1. Okay, and then we'll graph it, and we'll come back maybe and do our domain and range. So let's see, what do I have here? I've got 1, 2, 1, 2. So this is the early stuff where the midline is just your x-axis. Okay, and we're not shifted left or right at all. Pretty easy stuff. So just count by pi over 6. So we got 1 pi over 6, 2 pi over 6. Now, if you need to do this up here on the top, 2 pi over 6, 3 pi over 6, 4 pi over 6, something like that. If you need to do some of these on the top and then kind of reduce them, you can do that off to the side. So 2 pi over 6 is actually going to reduce to 1 pi over 3. 3 pi over 6 would reduce to pi over 2. 4 pi over 6 would reduce to 2 pi over 3. And that's our period, so we should be done there. We can do a bonus point here, not a bad thing here. And then we'll go 5 pi over 6, and that can't reduce. Okay, so this was the tough part from this quiz, was just learning how to kind of count by pi's with fractions. Okay, make sure we reduce those fractions. Amplitude of 1, cosine starts on the top. Okay, then it's midline, and then it's bottom, midline, back to the top. There's our full period, 2 pi over 3. Okay. And we could do our next bonus point here. All right, it could keep going on forever this way and on forever this way. Okay, remember on a quiz or a test, I'm going to need you to label. I know it's kind of a pain, but label these, write them down, 0, 1. Pi over 6, 0. Pi over 2, -1. Did I get off there? That was pi over 3, comma, -1. This is pi over 2, 0. 2 pi over 3, 1. See how easy that was? Piece of cake. That took me 15 extra seconds. Okay? Domain and range. Domain, your x's. This keeps going forever left and right, so that one's all reals. Range, look at up and down, up and down, up and down. Okay, we're bouncing back and forth between 1 and -1. All right. Let's see what happens with this one. Okay, well actually this one's going to be about the same. Look at, it's got a 2 in the front. So what's the only thing that's going to change for that? The only thing that's going to change, because it's the same thing, cosine of 3 theta to cosine 3 theta. So the only thing that's going to change is your top and bottom. Is that now for this one, this is going to go up to 2, and this one's going to go down to negative 2. Okay, and you should have this answer key. It's going to look like that. So this is still the same. Boom, boom. Amplitude is 2. Domain is still all reals. Just that we're going from 2 down to negative 2. It's much steeper. Okay. Let's look at a tangent problem. Ooh, 1/4 on the inside. So we're going 1/4 as fast. We're actually slowing down. Okay, the normal period for tangent, now tangent and cotangent are the weird ones. The normal period for those is just pi. And I divide by whatever the multiplier is. So 1 pi divided by 1/4, when you divide by a fraction, it actually gets bigger. This is going to be, the period is now 4 pi. Our counting numbers, there's only 2 counting numbers for tangent and cotangent. So 4 pi divided by 2 counting numbers means we're counting by 2 pi's. Okay? 1, 2, 3, 1, 2, 3. Amplitude, remember for these, is going to be NA. And we'll come back and look at domain and range after we get this graph going. Okay, so we're not sliding left or right. We're not sliding up or down. The only thing we're changing here on this first quiz in the first part of the test is going to be period and amplitude. And tangent doesn't really have an amplitude, okay? So we're counting by 2 pi's. So there's a dot at 0. Here's a dot at 2 pi. 4 pi. What if we go backwards 1? Negative 2 pi. So tangent, you're either a 0 or an asymptote, and tangent starts with a 0 on 0. Okay, so then this one's an asymptote, and I'm going to want you to have one full tangent graph bracketed in with asymptotes. So if you kept going this way, you're going to have to go a ways, because then there's going to be another 0, and you're going to have to go a ways to get this one, would be your first one that's fully like walled in. So let's go backwards. Let's do this asymptote over here. Okay. Next, we have our amplitude that we don't really use, but we kind of use. There's really like a 1 right here. So halfway between 0 and my asymptote, I'm at 1. And on this side, I'm going to be at negative 1. And it's not just a straight line. Okay, this is a nice one because halfway between 0 and 2 pi would just be 1 pi, negative pi. And this is going to help me kind of curve like that. Okay, and again, make sure we label our dots. Negative pi, negative 1, 0, 0, pi, comma 1. That took 10 seconds, okay? It's not going to hurt you. All right, domain and range. Domain's going to be the weird one. Range, for this one, range is going to go up forever, down forever. That's all reals. Let's look at our domain. Okay. Which values are we not using? We don't use negative 2 pi. 0's okay. We don't use positive 2 pi. 4 pi would be okay. 6 pi would be an asymptote. 8 pi would be okay. 10 pi would be an asymptote. So that's every other 2 pi, but what's a smarter way we can kind of say that? This is 1 times 2 pi. 2 times 2 pi is okay. 3 times 2 pi, 6 pi, would be another asymptote. Okay? So these are going to be odd multiples of 2 pi. That's a tough one to get to. X is not equal to odd multiples of 2 pi. That's kind of a tough one to come up with. All right, same thing with this one. Again, it's the same period, same counting, just that our amplitude is 5, not really amplitude, it's NA, but that multiplier in the front is 5. So your halfway point is going to be pi comma 5 and pi comma negative 5. Okay, so it does kind of stretch it out a little bit, but at the same time it's going up and down forever anyways. So that's what it kind of like, not applicable. All right? Let's see if we can find one from the back side here. Let's do like a secant and a cosecant one. Let's do 2 times secant of half theta, okay? So secant starts with an S, which means its partner starts with a C. So this is really going to be partnered with cosine. So these have a normal period of 2 pi. Let's see, where did I start this on my answer key? Over here, about right there. So period 2 pi divided by a half. So when we divide by a fraction, it actually gets bigger. So the period is going to be 4 pi. 4 counting numbers. So 4 pi divided by 4. Ooh, that's small. Sorry. 4 pi divided by 4. We're going to be counting by single pi's. Okay, let's see what we got here. I think I did 2 on the top and 2 on the bottom. There's my x-axis. Counting by pi's. 1, 2, 3, 4. We'll go backwards 1. Okay. So secant is partnered with cosine. Our amplitude is NA technically, because secant and cosecant are going to go up forever, down forever. NA, not VA. Cosine is the partner one, so we're going to kind of shadow in or dot in the cosine graph. So cosine starts on the top, it's a times 2. So just for this little bit, we're going to pretend that counts. All right, so we're times 2, so we're on the top. Not at 1, we're at 2, because it's like 2 amplitude for the cosine. Okay, and then we're on the midline, and then we're 2 below, on the midline, back to 2 above. Okay, let's go backwards 1. Okay, now, where cosine would be 0, its inverse, secant, when you flip that upside down, 1 over 0, that's how we get these asymptotes. So wherever we cross 0, those are going to be the asymptotes. Okay, and to get your full graph, I need you to have bracketed in with asymptotes a top one and a bottom one. And then these dots on the top and bottom are your parabolas. And it just keeps alternating back and forth like this. Okay, again, we need to label our dots and label our asymptotes. So vertical lines are x equals. So x equals negative pi, x equals pi, x equals 3 pi. And just labeling those, that's really going to help me with my domain. Just saying that out loud. Negative 1 pi, positive 1 pi, 3 pi, 5 pi, 7 pi. Okay, what am I not using? My domain is going to be all x's except odd pi's. Okay, my range, sorry guys, I keep having to slide this out, range. Okay, it's not all reals, okay, because we have this empty space in the middle. All right, so this is at 2 going up, this is at negative 2 going down. So my y values are greater than or equal to 2 or less than or equal to negative 2. Okay, and let's not forget to label our dots. See, I labeled the asymptotes, and I forgot to go back and do the dots. 0, 2, 2 pi, negative 2. All right, and I'm not going to use that one. We're going to pretend I didn't do that one. Again, not very difficult, okay? I don't think I'm asking a whole lot to go back through and label like 4 or 5 dots, okay? Let's see how we're getting to be. About 15 minutes. That's probably it for your attention span. Cosecant is basically the same thing, just with sine is going to be the original one that you use to dot out. Cotangent is the same thing as tangent, except it goes down and to the right instead of up and to the right. And cotangent starts with an asymptote and then goes 0, where tangent goes 0 asymptote. Okay, hopefully this refreshed your memory here a little bit on the basic graphing without any shifting, just adjusting the period and amplitude. If you have any questions, you can make an appointment, come in to see me, and we can work things out. But hopefully walking through a couple of those problems there and seeing the answer keys, hopefully knock the dust off and you're ready to go. All right, thanks, folks. We'll see you later.